Okay, so we're reviewing for the test, which is coming on Thursday. And the test is called algebraic manipulation number 2. So there's lots of algebra, lots of big fractions and fractions that are getting multiplied, and you got to clear denominators and all kinds of algebraic kind of stuff. So if you know from the past that the algebraic manipulation was the one that you were weak on last time, well then you better make sure you're ready for it this time. There were a lot of people that had to retake that test because it should hurt them. So anyway, let's talk about the domain of f. If you're going to find the domain of this, where do you look? Denominator. Okay. Would it also matter if there had been a square root? Would you look in there then too? Yeah, you would. But in this one, you just look at the denominator. And what can't x be? X cannot be -2. So then that becomes the range of that. What the heck does that mean? Of its inverse. So if we knew that this thing has an inverse, this function right here has an inverse, whatever the domain and range are for this, those are the domain and range for the inverse, except you flip them. The domain of this guy becomes the range of its inverse. All right, so the range of the inverse is the same exact thing. It's x is not equal to -2. Now, we would not ask you, I don't think, on the test to give you a range for this because you'd have to see the picture. We've only taught you how to do ranges with a picture. But I could ask you to give a range for something like this. If I gave you this function, and I could say f of x instead of y, it means the same thing, but if I give you this function, what's the range of that one? 7 to infinity. If you know what the picture looks like, which is that it's a V shape that's been moved 4 to the right and up 7, it's fairly easy to say, oh yeah, that's from 7 to infinity, because the lowest it goes is 7, and all the way up to the highest it goes is infinity. So 7 to infinity is its range. So what do you then know about its inverse? The domain is 7 to infinity. Yes. All right. Look at this one. There's a way to prove things are inverses. Do you remember that little formula? If f of g of x is equal to g of f of x, and they both come out to x. In other words, you can't just say, oh, this one came out to 5 and this one came out to 5. So they are equal, so they're inverses. That would be wrong. If they don't come out to x at the end, then they're not inverses. Try it, please. See if you can prove that these either are inverses or that they're not inverses. My audio there because I forgot to turn my audio on. Okay, anyway, bottom line is that most people said false, and they are correct. It is not. These are not inverses. Why? Because when you are trying to answer this thing, this side does not come out to x at the bottom. In fact, the right side I don't think comes out to x either, but all it really matters is that if either side does not come out to x at the end, then the whole thing falls apart. They both have to come out to x to be a function, or sorry, to be inverses. All right, so if I'm going to show you how this was supposed to work by doing this. When you make a function, then you know that what you had originally and what you got our functions. So I want you to make a g of x for me. From this, make me its inverse. You remember the three-step process for that? First thing, you change this f of x to a y. Then you flip-flop them. Then you solve for y. This is classic algebra. It's just algebra. Can you solve for y now after you flip-flop them? Slippery shirt today. There we go. The test is called the algebraic manipulation. So okay, so to make this an inverse, you should have the algebra skills for this. You want to clear the fraction first. That's your first step. Get rid of this. So you multiply by y on both sides. So you got xy equals y minus 5. Then, try to get the y's alone. You got to get them together first. So this has to come over there. Xy minus y equals negative 5. Then, I got to get the y's alone. So I'm trying to get down to just one y. So I factor the y out. That's the biggest, hardest part. Sorry. X. Yeah, actually I had that right. Y comes out x minus 1. Then I have to divide by x minus 1. Then this will cancel this, and y is now alone. Raise your hand if you had that one right. Okay, good. So now, I've got my little function. I have now done its inverse, and it's negative 5 over x minus 1. Negative 5 over x minus 1. Now, since we know that those are functions, we can be sure that this time when I ask you to try to prove that they are functions, that it should actually work. So, would you take a second and do that f of g of x and g of f of x and make sure they actually both come out to x? Because if you can't prove it on this one where you know it's going to be right, then you have no hope. Unless you learn a lot between now and Thursday. Okay, so try g of f of x, see if it really simplifies down to x. It should. Well, let me move that thing. That's fine. Don't care. All right, you're supposed to be putting the g function into the f function. So I'm going to start with the f function and make empty spots so I can drop g into it. So I just copied that function down with empty spots. I'm going to drop the g into it. Negative 5 over x minus 1 and negative 5 over x minus 1. Now this is the part where you have to remember how to clear a fraction. That's algebra stuff. And to clear this fraction, I have to multiply the top and the bottom by the denominator, x minus 1. And here's what everybody forgets. They think, oh, see, I cancel it because there's one in the denominator there. But they forget you got to also multiply it by this. You got to multiply this by both parts. So it's true that when you do this part of the multiply, the x minus 1s will cancel, and you have negative 5 left. I should really get this out of here so I have room. Clear out that red bar. There. Negative 5. Then you do this times this, and you have negative 5 times the x and negative 5 times the negative 1. So it's negative 5x plus 5. All over. On the bottom, at least there's only one thing you're multiplying. This times this. And the x minus 1s are meant to cancel each other. That's the point. This is like over 1, so it's on the top, canceling 1 on the bottom. Final answer, negative 5 down there. Now, to do this in the right order, this and this should cancel next. Plus 5 and the minus 5, and you're left with negative 5x over negative 5, and then the negative 5 cancel, and you got x. Raise your hand if you were able to make it to x. All right, good. That's how you get it down to just x. And now I'd have to do the other side, which is g of f of x, and make sure that comes out to x, which it does. and then your x on one side and the x on the other side proves that you have functions or inverses of each other. Yes, sir. And did it come out to x? Excellent. All right. Because when I multiplied this times this, do you see how the x minus 1s would cancel each other, and that leaves me only the negative 5 left? That's how. Why did I multiply by x minus 1 on top and the bottom? Because this over this is equal to 1. That's okay to multiply as long as you do the same thing on the top and the bottom. And the reason I chose that is because it would cancel my denominators. My denominators were x minus 1s. All right. You have to know how to do that. This is where you decide if you're going to be the A or the B student, is if you can handle things that are more complicated like this. That's how you get the A. Okay, and these are the kind of things you have to know how to do. You have to be able to handle big fractions, canceling denominators, taking fractions that are in fractions and flipping them and multiplying, all that kind of stuff. Yes? Sure. I'm just going to hit back on this like a bunch of times. No, it's not going to let me. Okay, and I'm going to go with this. Okay. That's pretty close. Okay. Do you get how I had the blue stuff there? Okay. Do you get why I multiplied by x minus 1 over x minus 1 in black there? It'll make these guys cancel. Okay. Now when I take this times this, that's what happens. I'm going to blow that up. Negative 5 over x minus 1 is being times by x minus 1. And when this part happens, the red part, then the top cancels the bottom. Now I have negative 5 left. That's right there. When I do the x minus 1 times the negative 5, that's where I get the rest of this stuff. So this has to be multiplied by two things. The first part is where the x minus 1 will cancel. The second part is where the x minus 1 won't cancel. Okay. All right, let's move on. Prove that they are not, or are not inverse. Wait a minute, we just did one like that. That's good enough. Let's move on. Here's two functions, f of x and g of x. And they give you a domain. We will do that sometimes. We will just say this is the domain. Even though this normally wouldn't have any restrictions on it, it would normally be negative infinity to positive infinity. A lot of times we'll just say, use this domain for it. Okay, the other one we don't have is d of g. Would you please figure that out right now? Write it on your paper. You got two functions, you got to know their domains. Got to know there's four pieces of information there. F of x and its domain, g of x and its domain. Once you got all those pieces, then you can do these kind of problems. So did you say that x minus 2 had to be greater than or equal to 0, so x has to be greater than or equal to 2? Good, that's what you should have said. Okay, so there's your domain of g. I got my two domains now. So if I'm going to do an add problem, all I have to do is take these two domains and draw them as number lines and overlap them. Because those are the simple kind. The adding or subtracting or multiplying kind are all the simple, just overlap them. Here's 5, and it's less than or equal to 5. Here's 2, and it's greater than or equal to 2. Do you see where the overlap is? Between 2 and 5. So do 2 to 5 brackets. That's for add, subtract, multiply, the easy kind. How about domains for the hard kind? You have to know a formula. If you know it, for finding this one, which is also known as f of g of x, if you know the formula for finding that domain, it starts with d of g. Write it on your paper. You got to have that one memorized. Okay, hopefully you wrote. For this kind, you would go d of g intersected with g of x in d of f. Raise your hand if you had it right on your paper. Good. And you have a decent chance at this. Because now you just have to plug things into your formula. The domain of g. I see it. It's right here. x is greater than or equal to 2. Fill in the rest of the parts of the formula. Let's see if you can finish this deal. No, just sit there. I know you can't do this without a pencil and paper. G of x is square root of x minus 2 in d of f, which is right here. X is less than or equal to 5. So now I'm going to go put this into this. So the right side's already done. I'm all ready to draw a number line for that and overlap it with something. But I got to finish the right side first. Square root of x minus 2 is less than or equal to 5. Square both sides. Does not cause an absolute value thing. That's when you square root both sides. X minus 2 is less than or equal to 25. Add 2 to both sides. X less than or equal to 25. All right, and I have this one. X is greater than or equal to 2. Thank you, 27. I knew it in my head and I said 25. I don't know why. I was thinking 27 when I said 25. Okay, so there it is. How do I finish this deal? Make 2 number lines. Really, it's the best way. Here's 2, bigger than or equal to. Here's 27, less than or equal to. Where do they overlap? Between 2 and 27 with a bracket. How many had that domain right? Okay. So that's f of g of x. That's how to find the domain anyway. Now let's just go back to plain old, what is f of g of x? Not the domain, just f of g of x. Go ahead and figure it out right now. F of g of x. That's the way easy part. That goes into that. So I start with an empty spot, plus 4, and then I drop this into it. Can I simplify that? The only thing I can do is drop the parentheses. X minus 2 plus 4. That's it. Raise your hand if you had that right. Good. That's all there is to it. How about f plus g of x? Try this one. I want to circle in blue. Try that. F of x plus g of x. Can I add anything together there? Nope. So I'm done. If I could simplify it, I would. There's nothing that can be added, so that's f plus g of x. The last one is f divided by g of x. Try this one, please. And the last thing is, write me its domain. And I'm going to see if any of you catch it. F of x is on top. G of x is on the bottom. That's not that complicated. Well, that's the right answer for f of x over g of x. But what it's a domain. Well, for these, you just overlap them, right? So this one was domain of g was that x had to be greater than or equal to 2. Okay. So then here's 2. Here's 5. Well, they overlap. So 2 to 5. All right, on your calculator, I want you to write true or false. That answer was either true or false. I'm going to insert, don't say the answer, please. I'm going to insert a instant true-false question. Doesn't look like it wants me to insert a true-false question. Hold on just a second. Maybe there's one of these that has a question that's not stopped or something. Yeah, it's this. I didn't stop that question. Come on. You guys see where it says to stop the question? That seems like a flaw. Stop assessment. There we go. Okay. Good. So now I'm going to go back to that. This one here. Oopie. No. This one here. And ask whether or not 2, 5 was the right answer. So I go. Okay, I'll try to start this class again. All right. Try signing in real quick. Is it letting you in? Or not? Okay, you know what? I think I've heard that. Okay, try it twice. I've heard that the smart recorder doesn't like to play nice with the Centio. And I think they're right, because now it won't let me ask an instant question. So, sorry about that big waste of 4 minutes there, but I was trying. Okay. What do you say? True or false? False, because you can't allow the bottom to be 0. And if 2 was allowed, 2 would make it 0. So this has to be a curve. Raise your hand if you knew that. Good. All right, then you caught the little curveball involved in that one. All right. Last thought is one-to-one function. Is this, first of all, a function? Yes, because it passes the vertical line test. But what does the horizontal line test tell us? Whether its inverse is a function. Is this guy's inverse a function? No. So is it a one-to-one function? No. What if its inverse had been a function? Then it would be one-to-one. All right. This one. Is it a function? Is its inverse a function? So what kind of function is it? One-to-one function. Because it passes the vertical line test and the horizontal line test, then it's a one-to-one. All right. Good. Covered everything that you need to know for now. So today, the rest of the day is going to be a work day where I have a worksheet here, and you'll be able to probably get most of it done in class. The rest of it you do is homework. Tomorrow you come with it all done, and then we talk over any problems that you had with it, and then you have a bunch of time to just plain study, like memorizing formulas. There's a bunch of them this time. Practicing fractions over fractions, being able to handle canceling fractions. That's going to happen. There's other things. I'll talk to you more about how to study tomorrow.